Okay. So I'm going to try to keep it nice and short, nothing too crazy. I know the first page you see on your packet looks like this. Okay, we're going to use this in a bit. Just move it off to the side. I want you to be on this page for now. All right. First things first, make sure you understand that the lesson we're about to learn is called Intro to Stoichiometry. And then I even tell you how to say it, so Stoichiometry, okay? So basically, what is stoichiometry? First, we're going to consider the situation. You know, if I was in class, I would act it out. But we're just going to do it through the video. So it says, you and the people at your table crash land on an island after 2 days of waiting with no food or water. You are all dying of thirst. Emphasis on thirst. You scavenge the airplane and find a small 25-gram bottle of rubbing alcohol. Rubbing alcohol looks like this. C3H8O. So that's the chemical formula for rubbing alcohol. So I gave you a couple options. Do you drink the alcohol in hopes of going blind and dying faster? Use the aluminum oxide catalyst that your friend had in their pocket, which converts 100% of the alcohol into water, as shown in the reaction below. Boom. Or do you burn the alcohol inside of a bottle, shown in the combustion reaction below? I'm going to let you know right now it's going to be option C, because this is going to show you what is it that we're basically going to be doing in the next couple of lessons, right? So what I'm about to show you is what you're going to be learning, but it's going to look a little complicated. So you're just going to go ahead and follow along with this first part. The only thing I give you, like as always, in the question is the 25 grams of alcohol, okay? So again, this is just a crazy example, so it shows you what is it that you're going to learn. So you have 25 grams of that C3H8O. Looks like that. All right. And then what you're going to do, since we have that as our compound, it's going to basically look like this. You're going to find the molar mass of alcohol. It turns out to be all this. C3H8O over 1 mole, because that's a conversion mole map that we've all been using, right? Nothing crazy. But what you're trying to do is you're trying to turn this into water. So we have to get from one type of formula all the way to a different type of formula, okay? To do that, we did learn how to do mole fraction, because remember I was saying we start off with one type of mole, we're trying to get to the other type of mole. So like how many pieces of cheese for how many pieces of buns. That's what this mole fraction is coming into. So this is the lesson where you're going to put everything together. So here it's going to be 8 moles of water. And on the bottom, you're going to have 2 moles of C3H8O. Okay? And you're probably like, well, Ms. Chavez, I don't understand. Where did you get these numbers from? And again, this is just kind of like an example of what it is that it's going to look like. 2. So that's where I'm getting them from. Again, the mole fraction is literally just because you balance it out. That's the only time you're going to use these numbers. The last part is going to be, I want it to go all the way to grams of water. And then 1 mole of water underneath. Turns out you get about 30 grams of water if you were to convert your alcohol into water. So what I did here is I want to go from grams of alcohol and I want to somehow get to magical grams of water. So the only thing you have to worry about every single time, if you start with grams of whatever this is, bananas, cucumbers, or excuse me, in this case, alcohol, down here you want to have the same unit. The only conversion that goes on top, you know it's going to be 1 mole for every whatever molar mass this is, which is why my first fraction looks like that. Then if you notice, because I have moles of alcohol up here, I have moles of alcohol up here. That's how I know what goes at the bottom. And then again, this mole fraction comes straight from the coefficients. Then the last part, because I'm trying to, again, get to grams of water, moles of water, moles of water. And then you just multiply everything at the top together, divided by everything multiplied at the bottom, and you get 30 grams. So this is what it's going to look like once you put everything together, okay? But in order to do that, you need to break it down. So here's an example. If you have 2 slices of bread, how many hamburgers can you make? And this is where you fill it out. 1 burger. If you have 8 slices of bread, So if you know 2 can make 1, 8 slices of bread, how many burgers can you make? You're like 4, right? Okay. Same thing in this situation. If you have 1 mole of oxygen, how many moles of water can you make? So if you have 1 mole of oxygen, how many moles of water can you make? Boom, 2. So you're gonna put 2 moles, right? This isn't part of that equation. You're like, okay, I know 1 is 2 because I can see that here. Now I'm asking you, okay, you got 3 moles of oxygen. How many waters can you make? If you know 1 mole can give you 2, 3 moles can give you 6. 6 moles. Basically, you just multiply this times 3, gives you 6. You couldn't even see that, my bad. All right. Then what you're gonna do, I'm gonna go ahead and do the first 2. And then I'll let you do the rest by yourself. So for this first one, let's say my coefficient for A is 2. Say my coefficient for B is 9. Say my coefficient for C is 5. All right. This is the setup how it's always going to be. You have grams of A, 1 mole of A on top, grams of A at the bottom, because I know y'all like a nice little cheat sheet. Moles of B, moles of A, and again, this is your mole fraction. And this is where you use your coefficients. All right, this is the only time you use these numbers, and you plug them in there depending on what mole you're talking about. Last part is going to be grams of B, 1 mole of B. Just in case you forget, the grams, you get them from your p-tab. The grams, you get them from your p-tab. Okay? So I have my given. Typically is going to be your grams of A. So this will be your given. Then you're going to find this on your p-tab. 1 mole of that on top of A. So if this is, I don't know, water. Grams of water, 1 mole of water, grams of water. Moles of water, moles of, I don't know, alcohol. Moles of alcohol, grams of alcohol. Let's say that was B, right? This number you're going to get from up here. So, okay, mole B, boom, mole B, that's a 9. Mole A, boom, mole A, that's a 2. And that's the only reason why you're plugging these, because again, you get them from the coefficients. All right. And we're going to move on to the first question. First question says bornite, and just in case you don't know, I always give you the chemical. If you don't know it, I'm always going to give it to you. Is a copper ore used in the production of copper. When heated, the following reaction occurs. Boom, 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 boom. If you begin the reaction with 75 grams of oxygen, that's your given. That's all you need. How many grams of solid copper would be produced? And this is your once. All right, I'm going to go ahead and set it up just like how I have it up there. So I have 1 fraction here, I have another fraction here, I have another fraction here. This is your A. I'm going to go ahead and highlight it. This is your B. I'm going to highlight it in pink. All right, start off with your givens. The only thing, again, you're given is that 75 G's of oxygen right there. So since you have A, and A, that's going to be A, and A. Then your B's in pink, so that's going to be B, and B, B, and B. Okay, so grams of O2, you're going to have grams of O2 down here. Make sure they are the same unit. Okay, they have to be the same in order for you to cancel them. Since it is 2 oxygens, I'm going to go ahead and find the mass of 1 oxygen times 2. Gives me that. On top, I'm going to follow along, is 1 mole. 1 mole of your A, which is O2. That's why I have it highlighted, see? Then moles of O2, if you follow it, moles of A, go down here. Then you want mole B. We know our mole B is copper, so moles of copper on top. Then again, my pink is still copper. So I'm going to put copper here. Because you have moles of copper here, down here you're going to have moles of copper. Notice how they're the same diagonally, so they can cancel out. Always 1 mole, And then these are going to be the grams. See grams. Find this on your P tab. I only want 1 copper because it's just 1. 63.546. This you get from up here. You're like, copper, 6. You're like, O2, where's O2? 7. Boom. Then you're just gonna multiply everything on top divided by everything on the bottom, which should give you 127.67 grams of copper. Just in case you missed it, you know it's copper because look, grams of copper cancel out with grams of copper. Moles of O2 cancel out with moles of O2. Moles of Cu cancel out with moles of Cu, and you're left over with those units for your answer. Right? I'll let you do number 2 on your own and number 3 as well. I'm going to move on to part 2. So this is probably going to be the longest video just because there's a lot of parts to it. And the reason there's a lot of parts to it is because it gets harder each time. So for this next part, notes into intro to stoichiometry is going to be part 2, like how I said. So here, stoichiometry helps us predict. You're going to put how much of a substance a chemical reaction will produce. That's what we're trying to figure out. Just like how in the first example we went from alcohol to water because you needed it. Same thing here. So what I want you to do before we move on to like something harder, because all we did right now, is we went from grams to grams. Now it says you gotta identify what unit is paired with each of the following particles. Just in case you forgot, when it's positive, negative, it is going to be FUs. Remember? When it is negative, negative, it is going to be molecules. And when it is just one element, it is going to be atoms. So that's what I want you to do in this part right here. I'll give you a hint. This is a metal, this is a non-metal. You use your key, FU, which again stands for formula units in case you missed it. Okay, we're gonna move on to the next one. It says, how many particles of carbon dioxide are produced in the following reaction is initiated using 219 grams. This is the only givens of iron 3 oxide. Given. All right? If you notice, it's not balanced. So this is why it gets harder. So what you need to do is you need to balance it. All right, here you have 2 Fe's, here you have 3 oxygens, and you have 1 carbon. Make sure you leave a little bit of space because you're going to need this to figure out the stoichiometry. So again, stoichiometry is when you have your 3 fractions. So I can set that up already if you want. Then you're going to go ahead and write your Fe on this side, 1, your oxygens on this side, 2, and your carbons on this side are 1. Okay, I'm going to let you know right now my coefficients are 2, 3, 2, 3, 4, and 3. You will get practice balancing on the next question. 6, this turns into 3, this turns into 4, this turns into 6, this turns into 3. Okay? Then you're going to start with your givens, as always. So it is 219 grams of iron 3 oxide. That's iron 3 oxide. That's just carbon. That's just iron. And then that's carbon dioxide. So you're going to write the formula Fe2O3. And it's going to follow the same format from the previous question. So if you forgot, looks like this. Okay? So you want to go from iron 3 oxide, and it's asking for carbon dioxide. So that means carbon dioxide is going to be your B, and iron 3 oxide is going to be your A, which looks like this. All right. So this is A, that means this is A, that means this is A, and this is A. Just like that. I know the colors are different, my bad. That's B, that's B, that's B. As long as you know which one goes where, because this is B, that's what you're trying to get to. This is your wants. This is A, this is your givens. So then you're gonna write Fe2O3, you have grams of Fe2O3, so down here will be grams of Fe2O3. Up here, just like how you have it, 1 mole. 1 mole of Fe2O3. This you find from the p-tab is going to be 159.6 grams. Then we have our mole fraction. Make sure down here it's just A. We know our A is Fe2O3, so moles of Fe2O3. We know our B, because it's highlighted in yellow, will be CO2. So moles of CO2. Again, we find this from our mole fraction, so you're like, CO2, boom, 3. You find Fe2O3, boom, 2. Then moles of CO2, and again, it's highlighted in yellow, moles of CO2. How many moles is it always going to be? It's always going to be 1. Don't forget. 1. On top is going to be grams, just like how I have it here, grams of CO2. You find this, but you would say grams, right? But since here it's asking for particles, make sure you understand where to go when you're using your mole map. So remember, your mole map has 1 mole, and it has the option of going to either particles, it has the option of going to mass, and it also has the option of going to liters. So now we were doing mass, but since it's asking for particles, we have to go that way. So that means up here, instead of having grams, you're just going to have particles. And when it's asking for a specific type of particle, which we practiced, CO2 is 2 nonmetals. So because it's 2 nonmetals, it's going to be molecules. If I lost you here, just use the mole maps. Use this one, the one that we've been using. That's all you got to do. The main thing that's going to change anytime we have different units that it's asking you for is this top portion here. Everything else is going to follow this method. So it'll still be moles, grams, it'll still be moles and moles, it'll still be grams and grams. Typically the only thing that's going to change is going to be the endings over here. In this case, that's the ending that's going to change right now. And then how many molecules is going to be the 6.02 times 10 to the 23rd, because remember that's what's in the mole map whenever you go back to look at it. Then you're going to multiply everything together, like always, and you get 1.24 times 10 to the 24 molecules of CO2. This is a 4. Okay, go ahead and do the next part, which is question number 1. And just so you know, the way I'm going to be grading you, you'll get 10 points for every correct balancing. So make sure you have to balance correctly. Otherwise, you're not going to be able to put in the coefficients correctly into the mole fraction. And then you get 5 points for every fraction, including the number, the unit, and the chemical formula. So an example of this would be like 4 grams of water. And that needs to be shown in every single part of the fraction. So a good example of what the perfect score would be, for example, 219 grams, and then I have my chemical, and then I have my first fraction, and then I have 160 grams of Fe2O3, then I have moles of CO2, then I have moles of Fe2O3, then I have 1 mole of CO2 at the bottom, and then I have 6.02 times 10 to the 23rd particles of CO2. So basically this setup is just like the last question that we just did, but if you notice there's a couple of things missing, right? So what I want you to do is I want you to just go ahead and pause real quick and just see what grades you would give to see if you even met the grading format that I'm looking for. So if you notice, did you balance correctly? We don't know because it's not even in here. So you wouldn't even get the points for balancing, right? And then, did you fully put in every single number, unit, and chemical formula into this first fraction? No, you're missing the chemical formula. So you would miss 5 points right here. You go to the next fraction, you're missing numbers here, so you would miss 5 points right here. You go to the next fraction, You didn't put the correct particles because, again, particles is not a unit. Particles means that you can go to either molecules, that you can go to FUs, formula units, or you can have atoms as your unit. Because remember, particles is like the genre, and this is like hip hop, R&B, indie, rock, whatever you want it to be. So you would definitely not get a point. Ooh, my light turned off here. And you would not get a point here. And you would also not get a point here. Okay, so go ahead and finish off the next question. And then the last question we're about to go ahead and do right now. Let me just turn off this light. There we go. All right, last one. I know this is a long video. I'm sorry. This is going to be the longest one. So last one is going to be part 3. It says the training wheels are coming off because they are. They are coming off. All right. For each problem below, you will need to read and identify your chemical formulas. You will need to write the reaction. I am not writing this reaction for you anymore. You have to start writing them. You will need to crisscross and check for diatomic elements when necessary. You will then have to balance the chemical reaction, and then you will need to use the 3 fractions to convert what is given into the desired product. In case you forgot what diatomics are, those are the Brinkelhoffs. So those are going to be the BRINCL, and F, right? Then I go ahead and give you this. All right, here's the last part. So of the stoichiometry, I'm using what's it called? The disinfectant wipes, because, you know, that's what I use for a stand. Y'all already know. All right, so this is where that first page that I was like, oh, don't worry about it yet, is going to come in handy. So the givens will always be the same. The mole will be on top. This is whatever it's asking for, depending on the givens. Your mole fraction will stay the same. You have to look at the coefficients from the balancing to know what the heck goes in here. Then that last part depends what you're trying to get to. So that's why I put stars up here. The stars are going to be one of these 3 options, whatever it's asking for. All right. And then these are the units that go next to it. And then mole B and mole A always stay the same. Mole B, mole A. And again, the stars are going to be varying, or not varying, but they're going to be different depending on what the heck the question is asking you for. So we look at the first one. Sorry about the wipies. It's okay. Okay. The first one has this big old question here that I'm not going to read to you, but I'm just going to go ahead and highlight what I need. Yellow, if you can see it, is going to be my A. If you want to go ahead and get 2 highlighters, by all means, go ahead and do that, whatever floats your boat. And then this is going to be my B. All right. Here is my only givens. So that is my A of chunk of iron. Boom. All of that. That's my A. And I'm saying chunk of iron will react with water vapor to produce a brown solution of iron 3 oxide hydrogen gas. How many, here we go, liters of hydrogen gas will be produced? That is your B. That is what I'm asking for. So then you're going to go ahead and look at your setup from the first page. You're like, okay, given. So your given is 188 G's of iron. And again, this is your A. Then you're going to keep on going. First fraction. You're like, all right, if I have G's of Fe, I'm going to have G's of Fe down here. How many G's? That is what you're going to find in the periodic table. I'm going to go ahead and keep going. On top, we are still going to have 1 mole of A. So 1 mole of A, which is 1 mole of my iron. Boom. I'm going to keep on going with my next fraction. Your next fraction is going to be your mole ratio fraction. All right. You will figure that out later. But you can go ahead and start inserting everything. So you know at the bottom should be mole A, as so, mole A, mole B, Mole A again is your Fe, so mole of Fe. Mole B is going to be your H2. Then the last part says how many liters. So again, you see how there's a little star on top of the very last fraction? Because the last part is going to be one of these options. I'm asking for liters, specifically these amount. If I'm asking for grams, you got to find it on your periodic table. If I'm ever asking for atoms, molecules, or FUs, that's the number you're going to put on top. And these three options are going to go straight into this star section, depending on what it's asking for. Since I'm being asked for liters, I'm going to go ahead and use 22.4 liters. And I'm going to put that right here. 22.4 liters of hydrogen. And just make sure you put the bottom one, which is 1 mole of B. So 1 mole of H2. Please make sure you use the cheat sheet mole map. It's going to help you out a lot. And you're probably questioning yourself like, okay, I have everything. I have a couple missing spots. Where am I going to get these numbers from? And you're like, well, do I even have a chemical reaction to go off of? And the thing is like, you don't have a chemical reaction, so you had to make one. So that's where this little space up here, you can do it up here however you want, it's going to be for. So you have iron will react. So iron, when you hear the word will react with water. Water we all know is H2O. Okay, for now I know it says chunk, vapor, don't worry about what physical state it's in. To produce, it's going to be your arrow. Brown solution of iron 3 oxide. This you have to remember, okay, it's telling me that 3 belongs to iron. We know oxygen has a 2 minus. It looks a little messy, so we got to clean it up. Fe3O2. So Fe3O2. And when we hear the word and, it's going to be a plus sign. Hydrogen gas, which we know is H with a 2. It has a 2 because it's one of the Brinkelhoffs, one of the diatomic, plus H2. Okay, this is your formula. It is not balanced, as you can tell, because there are 1 iron here, there are 3 irons here, so you got to go ahead and balance that. I'm going to tell you right now that the equation is going to be looking like this. 2Fe plus 3 H2O will give you, this B is part of that question, Fe2O3 plus 3H2. And again, you're only going to use the coefficients. In this case, you look for moles of Fe. Moles of Fe, you're like, okay, 2. So 2. Look for moles of H2. You're like, okay, moles of H2, 3. So 3. That's the only reason why you're balancing to fill up this. Then you're going to look for grams of Fe, which you look for in the periodic table, 55.845. And then you're done. That's pretty much it. You just got to know where you go, how to get there, what to fill in, what your chemical equation is going to look like, and you got to make sure you balance it. All right? Then when you figure it all out, it should come out to be 113.11 liters of H2. And that is it for day 1. Go ahead and try the next part. Make sure you do your exit tickets, and then we'll see you in the next lesson.